Hello students, welcome to lesson 10 on trigonometry. I hope you are all doing well. Good. The last time we met, we looked at evaluating trig ratios of acute angles. So we solved an example and then we looked at the I, and then I gave you the I as an assignment. I hope you've all done the assignment. Good. So we'll begin our lesson today with solution to the assignment. Now before we move on, you remember we established the fact that tan theta is the same as sin theta over cos theta. So you have to keep that in mind. Tan theta is always the same as sin theta over cos theta. So tan theta is equal to sin theta over cos theta. So keep that one in mind. Good. So we found tan theta to be 1, and then we found sin theta over cos theta also to be 1. So we established that tan theta is what? Sin theta over cos theta. Good. So now let's quickly look at the solution to the third one. So I. So we're to evaluate 2 over 1 plus sin theta. And then we're giving sin theta to be what? Root 2 over 2. So 2 over 1 plus root 2 over 2. So we have substituted. Now we have a fraction. So we need to simplify the denominator. So we are going to have 2 over another over, you maintain this 2, 1 goes into 2, 1. 1 times 2 is 2, plus 2 goes into 2, 1. 1 times root 2 will give you what? Root 2. So this is what you have. So now we can write this one in this form as 2 divided by 2 over 2 plus root 2 over 2. Okay, so we are now having 2 divided by 2 plus root 2 over 2. I hope you are with me. Good. So now we will change the division to multiplication, and then we find that we reciprocate this side. So we are going to have 2 times 2 over 2 plus root 2. So when we multiply, we are going to get 4 over 2 plus root 2. 4 over 2 plus root 2. But we are not done. At this point, we are not done because we have a fraction. And then the denominator is what? It's a term involving what? An irrational number. So it involves an irrational number. So once you have a fraction where the denominator involves an irrational number, you have to what? Rationalize. Okay, so with this one, because there are 2 terms, okay, we rationalize by using the conjugate of this denominator. So we multiply the numerator and the denominator by the conjugate of what? Of the denominator. If it were to be just a term, then which involves a square root, then we'll multiply the numerator and the denominator by that same what? Term. But once it involves 2 terms, it involves 2 terms, we multiply the numerator and the denominator by the conjugate of what? Of the denominator. And the conjugate of this denominator is these 2 terms, but the sign will change to what? Subtraction. You did this one in set. Good. So let's move on. So you rationalize by multiplying this one by 2 minus root 2 all over 2 minus root 2. Okay, so when you expand, we are going to get 4 into bracket. You multiply, you're going to get 4 into bracket 2 minus root 2. Then all over 2 plus root 2 in one bracket, 2 minus root 2 in another bracket. Okay, good. So now looking at the denominator, it has the it has the form of difference of two squares. Okay, when you factorize difference of two squares, this is what you are going to get. So it has that form, so we rewrite it in that form and then we simplify. So we are now going to have 4 into brackets 2 minus root 2 all over 2 squared minus root 2 squared. Okay, so you either do it this way or you expand it and then the answer will come by itself. Okay, so either you expand these two binomial terms or you use difference of two squares, but it's simpler to use difference of two squares. So now we are going to have 4 into bracket 2 minus root 2 all over 4 minus what? Minus 2, because this square root and the 2 will go. So finally we are going to have 4 into bracket 2 minus root 2 over 2. Okay, then this will cancel this 2 times. So we are going to have 2 into bracket 2 minus root 2. And when we expand, we are going to get 4 minus 2 root 2. So 4 minus 2 root 2 is the answer to the question. 4 minus 2 root 2 is the answer to the question. So students, this is the solution to the assignment. Compare it with yours. Where you didn't get it, make sure you check it out and then you make sure that you have it. Okay, good. So let me give you an additional question to solve, a try one. Okay, when you are free, you try your hands on this one also. Okay, so that you build your confidence on solving questions of this nature. Good. So now let's move on to our main lesson for today. So today we'll be looking at what we call trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles. So we already know what trigonometric ratios are, and we also know something about complementary angles in plane geometry 1. So we just want to recap what complementary angles are. Okay, so in plane geometry 1, you learned that two angles that sum up to 90 degrees are said to be what? Complementary angles. So complementary angles are basically two angles that sum up to what? 90 degrees. So it involves only two angles that sum up to what? 90 degrees. So what are some of complementary angles that we have? Give me some. So 60 degrees. What is the complement of 60 degrees? To be what? 30 degrees. So these two angles, 60 and 30, are what? Complementary angles. Why are we saying they are complementary angles? Because they sum up to what? 90 degrees. So you can have 20 degrees and then what? 70 degrees. You can have 45 degrees and then another what? 45 degrees. You can have 10 degrees and what? 80 degrees. So these are all examples of what? Complementary angles. They are two angles that sum up to what? 90 degrees. Good. So now let's transfer this relation into a right angle triangle and see what we can also deduce from there. Good. So assuming we have right angle triangle, let me label this one as theta, the angle here as theta, and then this one as alpha. Good. Now we also learned in our first lesson on trigonometry that one of the properties of triangles is that the sum of interior angles add up to what? 180 degrees. So when you add all the interior angles, it should be equal to what? 180 degrees. So let's see. Now this angle is what? 90 degrees. We know its value is 90 degrees. But this one and this one we don't know. So let's look at something. So since this is a right angle triangle, it's a triangle, the sum of interior angles should give us what? 180. So alpha plus theta plus 90 should be equal to what? 180. Okay, so you can bring the degrees. Okay, so now alpha plus theta, okay, we are grouping like term, is going to be what? 180 degrees minus 90 degrees. So we are going to have 90 degrees, and then we have what? Alpha degrees plus what? Plus theta degrees. So alpha plus theta is equal to what? 90 degrees. I hope you follow. So the sum of interior angles should give us 180 degrees. We did that. We grouped like terms. We simplified, and we are now having alpha plus theta equals what? 90 degrees. So let's look at something. What can you say about alpha and theta? What can you say about alpha and theta? They are complementary angles. Good. They are what? Complementary angles. Why? Because they sum up to what? 90 degrees. So once these two angles sum up to 90 degrees, they are what? Complementary angles. So this means that in every right angle triangle, the other two angles apart from the 90 degrees are complementary angles. So alpha and theta are what? Complementary angles. Why are we saying they are complementary angles? Because they sum up to what? 90 degrees. I hope you get it. So don't forget that in a right angle triangle, the angle here and the angle here are what? Complementary. So if this one is 60, this one will be what? 30, because 90 minus 60 will give us what? 30 degrees. I hope you get it. Good. So now that we have established the fact that in a right angle triangle, the other two angles are complementary, let's look at the relationship we can get or we can deduce from their trig ratios. Okay, let's look at the relationship we can get from their trig ratios. Good. So we have this right angle triangle. The sides are labeled. Okay, so the hypotenuse is C, the opposite in reference to the theta is A, the opposite in reference to the alpha is B, the adjacent in reference to theta is B, and then the adjacent in reference to alpha is what? Is A. So now let's find sine theta. Let's find sine theta. So sine theta, we know that sine is always what? Opposite over hypotenuse. So per our right angle triangle, the opposite is what? A. And then the hypotenuse is what? C. So it means that sine theta is what? A over C. Okay, sine theta is A over C. Good. Now let's find cos alpha. Cos alpha. So cos alpha, we know cos is what? Adjacent over hypotenuse. So from the diagram, cos alpha, the adjacent to alpha is what? Is A. So write down our A. And then the hypotenuse is what? Is C. So write down our C. So cos alpha is A over C. I hope you are observing. Good. Now, let's find sine alpha. Sine alpha. So we know that it's opposite over hypotenuse. So sine alpha will give us the opposite of alpha is B. So it's going to be B. And then the hypotenuse is what? Is C. Okay. Then let's find cos theta. Cos theta. So we also know that cos is what? Adjacent over what? Over hypotenuse. So what's the adjacent to theta? Is b. And what's the hypotenuse? Is what? Is c. Okay, good. So now let's look at something. Sin theta, we had what? A over c. And then cos alpha, we also had what? A over c. So what it means is that sin theta is the same as what? Cos alpha. I hope you follow. When we came to sin alpha, we got sin alpha also to be what? B over c. And then when we found cos theta, we got what? B over what? Over c. So it means that sin alpha is the same as what? Cos what? Theta. I hope you get it. Sin alpha is the same as what? Cos theta. So now let's look at this one. We have also established that this one and this one are what? Are complementary. So now theta and alpha are what? Are complementary, meaning that they add up to what? 90 degrees. So we are seeing that the trig ratio, okay, of complementary angles, okay, the trig ratios of complementary angles in terms of sine and cos are what? Are equal. So alpha, theta, and then alpha, they are complementary. When we found sine theta, we had A over c. When we found cos alpha, we had A over c. So it means that the trig ratios, okay, of complementary angles, okay, trig ratios of complementary angles are what? Are equal. So the sine theta is the same as the cos alpha. The sine alpha is the same as what? The cos theta. I hope you get it. Good. So let's draw conclusion. Let's generalize what we've just learned. So what it means is that in every right angle triangle of this nature, sine A will be the same as what? Cos B. Sine A is the same as what? Cos B. I hope you get it. And then also, if you want the angles to be the same, so you realize that this one we are having two angles, but if you want to write this same relation where the angles are the same, then we know that if this is A, the B is the same as what? It's the same as 90 minus what? A, because when you subtract A from 90, you get what? You get B. So in place of the B, we can put what? 90 minus A what? There. So that is how come this relation also what? Exists. So when you want the angles to be the same angles, this is how you put the relation. When you want it to be different, this is how you put the relation. Okay, so sine A is the same as cos B, or sine A is the same as cos 90 minus A. Can also say that sine B is the same as cos A. And when we want to write the angles in terms of B, then we are going to have sine B is the same as cos 90 minus B. I hope you get it. Good. So students, this is the relationship between the trig ratios of complementary angles. Okay, so sine of one of the angle is the same as what? The cosine of what? The other angle. Okay, good. So we would end here. The next time that we meet, we'll solve some questions around this relation so that we understand the concept very well. Okay, we'll solve some questions around this relation. Good. So till we meet again, revise, read ahead. Bye.